Have you ever felt like machine learning is some super complicated, out of reach topic for experts only? Well, if that's you, then you're in the right place. Today, we're going to demystify it and help you take your very first step into this incredible world. And we're going to start with a question you probably deal with every single day. All right, so think about this. How does your inbox just know what's junk mail? How does it filter all that stuff out? It's not magic, and it's definitely not some person reading your emails. It's machine learning. And by the end of this, you'll get the core idea that makes it all work. So let's get right to it. What even is machine learning? The key is right there in that subtitle. It's all about computers learning from data, instead of someone having to give them a huge long list of rules for every single little thing. Here's the big idea. The old way of doing things was to write code that told a computer exactly what to do, step by step. But with machine learning, we flip that around. We give the computer a ton of examples, a bunch of data, and we let it figure out the patterns on its own. It's a total game changer in how we solve problems. Okay, so what's really cool is that machines can learn in a couple of different ways. The easiest way to think about it is like this. It's the difference between studying for a test when you have the answer key versus trying to figure out a brand new puzzle with no instructions at all. To really get the difference, we're going to use two super simple, everyday examples. Let's put these two ways of learning side by side. So on one side, you've got supervised learning. This is just like studying with flashcards. You have a question, and on the back, you have the answer. The data is labeled. But on the other side, you have unsupervised learning. This is like someone dumping a giant pile of laundry in front of you and saying, sort it. You don't have any labels, but you can start to find patterns, right? You can make piles of whites, darks, and colors. So here is the bottom line. With supervised learning, you already know the answers. You have emails that are already marked as spam or not spam, and your goal is to teach the machine to predict that for new emails. With unsupervised learning, though, you have no answers. The goal is to just find hidden structures in the data, like, say, discovering different groups of customers based on what they bought. All right, now for what is probably the single most important rule in all of machine learning, especially when you're starting out. It's called the train-test split, and it's really all about making sure we're being fair and honest when we check our work. This one quote just says it all, doesn't it? I mean, if you gave a student a practice test, and then the final exam was the exact same test, a perfect score wouldn't prove they learned anything, right? It just proves they memorized the answers. Well, it's the exact same for our models. We don't want them to just memorize. We want them to learn. So, to stop the model from cheating, we split our data into three piles. The biggest one, the training data. That's the textbook. That's what the model gets to study. Then there's the validation data. Think of this like a practice quiz we use to fine-tune things. And finally, the test data. This is the final exam. We lock it away and don't touch it until the very end, so we can get one last, honest check on how well our model actually learned. Okay, enough theory. Let's see how all this stuff actually works in a real, simple code example. We are going to teach a computer how to tell different flower species apart just by looking at their measurements. So, the goal is pretty simple. We have the measurements of a flower's petals and its leaves, and we want to predict what species it is. For this, we're using the famous IRIS dataset. It's basically the hello world of machine learning, perfect for beginners because it's nice and clean. First things first, we bring in the tools we need from a really popular library called scikit-learn. Then we load our IRIS data and we split it into two parts. Just think of X as all the evidence, the measurements for each flower, and Y is our answer key, the correct species for each flower. And because we have that answer key, we know this is supervised learning. Next up, we use that all-important no cheating rule. Now, I know these two lines of code might look a little crazy, but don't worry about the syntax. All it's doing is taking our data and automatically splitting it into those three piles for us. The big 60% pile for training, a 20% pile for our practice quiz, and that last 20% test set that we save for the very end. And now for the fun part. We pick our model, in this case, a simple one called k-nearest neighbors. You don't need to stress about the math behind it. Just know that it learns by finding flowers that are similar to each other. Then we use this one little command, .fit. This is literally us telling the model, okay, time to study. Look at this training data and find the patterns. And just like that, it starts learning. So once the model is done studying, it's exam time. We use the .predict command to show it the flowers from our validation set and our test set, data it has never, ever seen before, and we ask it to make its best guess. So how did it do? On the validation data, our little practice quiz, it got about 97% right. That's fantastic. It's like getting a solid A on the practice exam. This makes us feel pretty good that it's actually learning something real. But now, for the moment of truth, the final test. And on the final test, a perfect score, 100%. Our model correctly identified every single flower it had never seen before. Now that is the power of machine learning. It didn't just memorize the answers, it learned the patterns so well that it could apply that knowledge to totally new examples. And just like that, you've seen the entire core process of a machine learning project start to finish. But really, this is just the beginning. Today was just day one of a much bigger, much more awesome journey. Here's just a little peek at what a full learning path could look like. You've already nailed day one, the absolute fundamentals. From here, you can get into different kinds of models, learn smarter ways to measure how well they're doing, and eventually start building your own cool projects from scratch. So seriously, congratulations. In just a few minutes, you've grasped the key ideas that power so much of the world around us. You've officially finished day one. The only question left is, what problem are